Alright friends, welcome back. In this video I'd like to go ahead and cover section 4.2 of your textbook, and remember that this is going to be the last section of chapter 4 that we cover, and we're going to have a quick quiz over this chapter over just the first two sections here coming up. But let's go ahead and have a look at what we need to do today, which is graph rational functions by hand. So here are the quick 4 steps to be able to do that. Very simply put, the very first step is you want to find your asymptotes. So we discussed how to do that in the previous video. After that, you want to get a feel for where your function is going to be crossing the x and the y axis. And then after that, reach for the TID4 to plug it into y equals and get a couple of extra points by pulling up the table. Plot those points, get a feel for what the skeleton of the graph would look like, and then just go ahead and connect those points with a nice smooth curve. So nice and easy to do, so let's go ahead and have a look at that. So here in example 1, we have f of x is equal to 1 over x minus 3, and we just need to go ahead and follow the steps for being able to create a picture of this by hand. So the first step that we'll go ahead and perform here is finding our vertical asymptotes. And so we said in the last video that in order to do that, you just need to go ahead and take your denominator and set it equal to 0 and solve. So here our denominator is nice and easy. It's just simply x minus 3. So if I set that equal to 0 and solve, add 3 to both sides, I simply get x is equal to 3 as my vertical asymptote. Okay, so remember that as a vux, and so I'm just going to go ahead and do a dashed line here at x is equal to positive 3 on my grid. Again, keep in mind the idea with an asymptote is that it is a boundary line that the end behavior of my graph will infinitely approach, but it'll never intersect or cross. Okay. Next, we'll find our horizontal asymptotes, and we will do that by comparing the degree of the numerator and the denominator. And so if we take a look at that, in the numerator we have 1x to the 0 power. In the denominator we have x to the first. So that is a degree of 0 compared to a degree of 1. And we obviously know that 0 is less than 1. So we said in the previous video that if the degree of the numerator is less than the degree of the denominator, then what that's automatically going to mean is that you're going to have an automatic horizontal asymptote of y is equal to 0. Or in other words, the x-axis happens to be your horizontal asymptote there, okay? And so we can go ahead and come over here to my x-axis and just go ahead and do another one of those dashed boundary lines just to kind of give us a better idea of what this picture is going to look like, okay? After that, we need to go through and find our x and our y intercepts, and so these are found in the exact same way that we've always found x and y intercepts for other functions. We're going to substitute in 0 for y and then solve for x in the case of our x intercepts. But the funny thing here is about these rational functions is that if you were to try to solve this for x, one of the issues you would run into is you would multiply both sides by x minus 3. Again, that would be to get rid of this division by x minus 3 here. This is that process of clearing the fraction. But on the left-hand side, you'll have 0 times x minus 3. That just makes 0. On the right-hand side, remember that the whole point of this was so that the divided by x minus 3 and the times x minus 3 would cancel out, and we're just left with 1 on the right-hand side, and obviously we know that 0 is not equal to 1. So what this means is that we'll conclude we don't have any x-intercepts in this function. For y-intercepts, however, we're just going to go ahead and substitute in 0 for x and then solve for y. So we'll have 1 over 0 minus 3, and then we'll solve that for y. Of course, we are going to be getting y is equal to a negative 1/3, and that is going to correspond to the following point. It'll be 0 and negative 1/3. That will be our y-intercept point to plot, okay? Now it looks like our grid is already incremented. 1 unit square is going to be a full unit. And so just to approximate this, what we might do is just go down what we might consider to be a third of 1 unit for my y-intercept there. And then all we need to do now is go ahead and reach for a couple of extra points from the TID4. That's something that I've already done here and grabbed a screenshot of. Again, the whole idea here is that you're reaching for the TID4, you're plugging this into y1, and then press second graph in the TID4, and it'll pull up this nice table of values for you here. And maybe just pick some nice ones to plot, right? Like maybe 1, negative 0.5, we have 2, negative 1, we have 4, 1, etc., etc. Those would be ones that you would want to go ahead and plot. So let's go ahead and do those real quick. So I've got the point negative 1, 1/2. I've got that. And then actually, I don't believe I plotted that one correctly. I think I did that completely backwards. So let's do that right. So I have 1, negative 1/2. There we go. Plotting points is hard. We have 2, negative 1. And then we have 4, 1. Again, I'm just reaching for a couple of pairs here that actually turn out to be pretty nice. And again, you just need to reach for enough to where you could start to get a feel for what this graph is going to look like. I already have my boundary lines in there, my asymptotes, and I have a couple of these points that are kind of giving me this feel for what the graph is going to look like. And once you feel comfortable that you feel like you have enough points, we go ahead and just approximate the rest here, like I say, with a nice smooth curve, making sure that our curve infinitely approaches those boundary lines as we go further towards infinity in both directions there. So I might start at the top here and then swoop this down. something exactly like that. So again, simple 4-step process. In the next example, I've already had that worked out. So if you want to go ahead and pause the video and take a look at example 2 in the notes and maybe try it yourself, then unpause the video and see if you get it right. Okay, hopefully you've had a chance to go ahead and take a look at that here. Here is example 2. You notice that it's the exact same process here. We're still going through finding your vertical and your horizontal asymptotes. We're going to go through and find your x and your y intercepts and plot those. And then a little bit of work down there at the bottom to kind of show that we're just plugging extra values into the function. This could be something as simple as reaching for the TI-84, just like we did in the last example, and getting some additional points to plot. But there we go. Okay. Moving on here to example 3, we'll go ahead and do this one together. This says f of x is equal to x plus 1 all over x squared minus 4. Again, the very simple 4-step process here is we just need to go ahead and find our intercepts first. Or sorry, not our intercepts, our asymptotes first. There we go. So we're going to set our denominator equal to 0 and solve. This turns out to be a difference of squares, and we've solved a lot of these different types of equations in the past. So I'll just share with you here that x is going to equal positive or negative 2 if you solve that equation, and that's going to tell us that we have those two vertical asymptotes here. So we have one at positive 2, which I'll just go ahead and dash in really quickly. And then we have one here, of course, at negative 2, which I will also dash in really quick. Okay, so it kind of seems a little bit odd that we have these two vertical boundary lines. So we just need to go ahead and continue through the process to make sure that we know exactly what this picture is going to look like. So next we're going to compare the degrees of the numerator and denominator. In the numerator I've got a degree 1, denominator I've got a degree 2. And we obviously know that the numerator here is going to be less than the denominator, so we are bottom heavy. So we have an automatic horizontal asymptote of y is equal to 0, aka the x-axis. Okay, and so we're going to have this horizontal boundary line right here at the x-axis. Nice and easy to dash in there just like that. And next we need to go through and find our intercepts. Okay, and so again, finding these intercepts is the exact same process as always. We're just going to substitute in 0 for y and then solve for x. So our function goes x plus 1 all over x squared minus 4. Again, whenever we clear the fraction here, multiply both sides by x squared minus 4. Basically what that's going to do is on the left-hand side, just multiply times 0 and result in a 0. And it's going to get rid of that denominator on the right-hand side, just leaving us with the numerator x plus 1. And then if we continue to solve this, we'll see here that if we subtract 1 from both sides, we are simply going to end up here with x is equal to negative 1, which remember corresponds to a point with coordinates negative 1, 0. Okay, so that'll be a point that we plot right now. So negative 1, 0, boom. Okay, now you'll notice that that point actually does cross one of our boundary lines here, and you may suspect that that is a problem, but remember that the idea with these asymptotes is that these are the places where my end behavior will infinitely approach but never touch or cross. Okay, so the ends of my curve will get very, very close to these boundary lines, so it's no problem that we actually cross a boundary line here in this problem. Okay, so for your y-intercept, of course, we're going to do the exact opposite. We're going to plug in 0 for x and then solve for y. So y is going to be equal to 0 plus 1 all over 0 squared minus 4, in which case it is pretty clear that this is going to end up resulting in negative 1/4, or in other words, the point with coordinates 0, negative 1/4. Okay, so we can go ahead and plot that really quick right here. So negative 1/4 approximately, just like that. And then again, the only thing left here to do would be to go ahead and reach for the TI-84 to get some additional points to plot. And that is something that I have a screenshot here for as well. Okay, so to save time in the video, I'm actually going to go ahead and skip on actually creating the actual picture of this thing. I feel like the more important bits of the problem are being able to get these characteristics of the graph, right? So being able to get your asymptotes, being able to get your intercepts, using the TI-84 to get some additional points to plot. I don't think you really need me to take you through plotting additional points here and drawing the curve. I think the point of what we are trying to get at here has been demonstrated. So again, in the next example, example 4, it's exactly like this one. So maybe pause the video again, give that a shot on your own, and then unpause to see what the result would be. Okay, hopefully you've had a chance to give that a shot. Here is example 4. And again, this is another example where we have a horizontal asymptote there in the x-axis, but remember, we can cross that if we're crossing it in the middle. Our end behavior just cannot ever touch that as it reaches towards positive or negative infinity here. So feel free to pause the screen and give this one a once-over, and then we're going to move on after that. Okay, so it turns out that asymptotes are not just vertical or horizontal. There is such a thing as a slant asymptote, or a asymptote that we might draw in as a diagonal line, okay? And so the way you know that you're going to have these is, in the last video, one of the things we said is that if you are top-heavy, right? So if the degree of the numerator is greater than the degree of the denominator, we said that there are no horizontal asymptotes. And while that is still true, one of the cases that you may be on the lookout for is if you are top-heavy, look out to see if the degree on top is one more than the degree on bottom. If that's the case, then you will automatically have one of these diagonal asymptotes, or what we call slant asymptotes, okay? And it says right here, in order to find them, we're just simply going to go ahead and do long division with what we've got, or remember that synthetic division can kick in those special situations where it applies, right? So let's go ahead and demonstrate that here. So for example 5, it says find all vertical and slant asymptotes of the function. Graph the function on your calculator and then zoom out sufficiently so that the graph appears as a line, okay? For the sake of the video, I'm not going to go ahead and worry about this set of the directions here. You guys can graph this function on your own in your TI-84. I feel like just that first part might need some demonstrating, right? So we need to find all the vertical and slant asymptotes of this function. Well, to find vertical asymptotes, that hasn't changed. We're still going to go ahead and take our denominator and set it equal to 0. And here it's nice and easy. It's a linear, so x minus 3 is equal to 0. Add 3 to both sides, and you're going to get x is equal to 3. That represents your vertical asymptote, okay? But for your slant asymptote, we're going to need to perform some division of polynomials here. So we're going to be dividing the numerator by the denominator and then seeing what the quotient actually ends up being, right? So one of the things that you may remember is that synthetic division is actually something you have the green light for if your denominator does look like this, right? So this is a denominator polynomial that has a degree of 1 and a leading coefficient of 1, okay? So if that ever happens, then that gives you the green light to do synthetic division. The 0 that we got out of that denominator, of course, was positive 3. And then we're going to just list out the coefficients of our numerator. Remember that we've talked about synthetic division in the past, so if you need to go ahead and look up a previous video on how to go ahead and perform some synthetic division, I might encourage you to do so. I'm just going to go ahead and blaze through this here really quickly, in which case we'll find that we end up with this right here, okay? So remember that the last number in your synthetic division, that is always your remainder, and the numbers that we ended up with here, these are going to be the coefficients and constant of what your result is, your quotient, right? And so because we took a quadratic divided by a linear, then that means that I can go ahead and pick this up by saying x plus 1 is what y is going to be equal to, okay? And so this actually does represent the equation of our slant asymptote. So remember that this is going to be a linear function, so this is something that looks an awful lot like y equals mx plus b, where we might say playing the role of m is 1 and playing the role of b is 1. Again, that creates that slant asymptote for us, so we can actually go ahead and plot that using the slope and the y-intercept as a dashed line, and again, that's going to be another boundary line that we'll never touch or cross. Okay, here's another example worked out, example 6. Again, just setting the denominator equal to 0 to find your vertical asymptotes, and then using long division here in order to go ahead and figure out your slant asymptotes. Remember that your denominator here is not something that gives you the green light for synthetic division. You're going to actually have to perform some long division there. So feel free to pause the video and read through that example and see about that one on your own. And then we'll take a look at the next examples. I actually already have these worked out here as well. So just so we can kind of take a look here, it's the same exact process, but if you decide that you don't have any horizontal asymptotes, you will have to check to see if your degree of your numerator is 1 plus the degree of the denominator, right? If it's just one more like it is here, the degree of the numerator is 2, the degree of the denominator is 1, that's just one more, right? Then we'll have to check for a slant asymptote. But the lucky news here in example 7 is that we have the green light to do synthetic division, which is something that is being demonstrated here. So we're finding our vertical asymptotes, we found our slant asymptotes, we went ahead and draw those in. You notice I have that diagonal drawn in. And then I'm still finding my x and my y intercepts, and I'm still plugging in extra points into the calculator. Again, there's a screenshot of that if you want to pause the video and read through that real quick. You may feel free to do so, but that gives us a lot of really good information to be able to go ahead and create the picture of the graph by hand. Okay. The next one, example 8, might be one that you want to try on your own. If you want to pause the video at this time and give it a shot, then unpause the video and see if you got it right. Okay, let's have a look at example 8 here. Hopefully you had a chance to try this one on your own. This is going to be another example of one with a couple of different vertical asymptotes. Looks like we have 2 vertical asymptotes. Just don't forget to be on the lookout for those difference of squares problems. You're going to have 2 results coming out of that. And then here, when you do the long division for your slant asymptote, you are going to get just simply y is equal to x. So that's pretty easy to plot. We find our x and our y intercepts. Apparently that's just going to be the origin 0, 0. And then there's some work at the bottom to show how we're plugging in some values that we might pick to to get on either side of the asymptotes to plot some new points. And here's a quick screenshot of the TI-84 with some values plugged in. You notice that on the TI-84, it's actually going to say error on -1 and +1. Again, that corresponds to your vertical asymptotes in the picture, okay? So feel free to reach for those TI-84s in order to get some additional points to plot. And that's actually all I have for this video, right? So very, very easy to go ahead and create the graph by hand. Probably the most important thing that we want to be practicing here after all is said and done is just being able to do all this algebra work, right? Being able to find your asymptotes, being able to find your intercepts. You know, in the case of you having a slant asymptote, remembering how to do your long division or your synthetic division, getting those asymptotes and getting those put onto the page. But I hope this video has been of some help to you. If you guys have any questions, then feel free to meet me in the chat. But that's all I have for this one. Thank you very much for your attention, and I'll speak to you in the next one.